Hey guys, today will be the last new lesson of the year, so summer is definitely upon us, which is I think a good thing for all of us with how crazy the last couple months have been. Okay, so what we're going to look at today is we're going to look at 9.8. Okay, 9.8, we're going to learn three different methods, or you should use the three different methods. We're actually not going to do the graphing method, so you can ignore those examples. We're going to skip those. I think the graphing is going to be kind of difficult without me there to kind of walk you through it and show and kind of help you with the buttons and all that type of stuff. So we're not going to do it by graphing method. We're just going to do it by substitution and elimination methods. Okay, but again, we'll still know how to solve them. Just going to kind of skip the one method. Okay, now when we're solving these today, what we're going to be solving is we're going to be solving a quadratic with a linear. Okay, so we're going to be solving parabolas with lines. Okay, when you have a parabola with a line, there's a possibility of three different answers. Okay, there's one possibility would be if your parabola and line intersect in two spots. Okay, so if you think of a parabola, and then you could have a line going through it, okay, there would be two intersections. That would be your two answers. That's what we're looking for. Okay, we're looking for where these two cross each other. Okay, now obviously we're not going to do it by graphing, but there's ways we can do it with substitution and elimination as well. Okay, we also can have where they'll just intersect once. Okay, now this would really only happen if it just intersected the very bottom. Okay, because if it intersects anywhere else, it's probably going to intersect it more than once. Okay, it could be on the side too, depending on how steep it is. Okay, and then the other possibility is we could have no solution. Okay, maybe it ends up looking like this, where they don't cross at all. Okay, so those are our three different possibilities. Again, we're going to skip the graphing ones and jump right to example 2 and show you the substitution and elimination. Those are algebra based, which again, I just think will be a little bit easier for us right now with everything going on. Okay, so first one on example 2a. Again, jumping to example 2. Okay, so you'll notice you have two equations. Okay, this one would be my quadratic because it has my squared. Okay, that would be my linear because it's kind of like our y equals mx plus b form. Okay, and what we want to do is find where would those two intersect if I were to graph them. Okay, and again, you can still check these by throwing these into the y equals in your graph. Okay, it's just finding the actual point is a little bit trickier, again, without me being present with you. Okay, so the first method we're going to do is substitution. Now, what you will do is if they're both in y equals form, it really doesn't matter which one you choose to substitute. Okay, in that case, I would probably just do the bottom one into the top because they're both in y equals form. You'll notice this is going to look very familiar because we did this back in chapter 6. We just did it with two linears instead of a quadratic and linear, but it's going to look the same way. Okay, so I'm going to replace my y with my 4 minus x. Okay, so I'm going to substitute in, so we only have one equation, we no longer have two. So I'll get 4 minus x equals x squared minus 6x plus 10. Okay, so again, replace the y, so now I only have one equation. You'll notice now I only have one variable as well. I don't have a y anymore. Okay, so now I have a squared. So now we're going to go to one of the methods that we've been learning in this chapter. Okay, so either square root, factoring, completing the square, or quadratic. Okay, so I'm going to go ahead and set it equal to 0. So that means I'd add the x over and subtract the 4 over. At this point now, you can use whichever method you would like. We probably don't want to do square root method because we have a bx. You could factor, you could complete the square, you could use quadratic formula. Okay, it comes down to whichever one you would like to use. Okay, these ones are fairly easy to factor, so I'm going to go ahead and factor. X and x, -2 and -3 will give me my 5 in the middle. Okay, so then if I set these equal to 0, I get x equals 2 and I get x equals 3. Now, typically that's been where we are done. However, all of the answers that we get for this section have to be points. That means I need an x and I need a y. Okay, so the 2 and the 3 are just the first part of the points. I need to find their matching y's. Now don't worry, it's not that hard, I just have to plug it back in. The linear one is the one it's easier to plug it back into. So if I plug my 2 back in, I get 4 minus 2, which is 2. If I plug my 3 in, I get 4 minus 3, which is 1. So our answers would be 2, 2, and 3, 1. So if you were to graph these on the calculator, that's where you should see them intersecting each other. Okay, again, if they didn't, then we would have made a mistake somewhere with those. Okay, we'll do one more by substitution, and then we'll look at the elimination method. Okay, on these ones you'll notice only one of them is y equals. Okay, this one is y equals, this one's not. So that means this is the one I have to substitute. Okay, if it's not y equals, I cannot circle it and substitute it. Okay, so we'll end up with x squared plus 11x minus 12 minus 30 equals 12x. So again, just replace the y with this whole thing. The rest of it's going to stay the same for us. Okay, again, I'm going to go ahead and kind of subtract the 12x over. So we end up with x squared minus x. I can combine these to get a negative 42 equals 0. Again, at this point is where you have your choice. Okay, you can factor, you can complete the square, or you can use quadratic formula. Again, they're all going to be fairly easy to factor, so you can go ahead and do that if you're comfortable with it. Okay, negative 42, I'd use a negative 7, and a positive 6 would end up giving me my negative 1. Set them each equal to 0. I get x equals 7, and x equals negative 6. So 7 and negative 6, okay, again, are going to be the starting points. So plug your 7 back in. Again, the linear one's the easiest, but if you want to do the other one, you can. Okay, so if I plug 7 in, 12 times 7 is 84. Okay, add the 30 to the 84, and you'll end up with 114. You'll notice your numbers get pretty big. Okay, this one, if you graphed it, you're not going to be able to see it on your screen. Okay, if you plug in the negative 6, okay, you'll get negative 72. Add the 30, you'll get negative 42. Okay, so don't be shocked if you get some bigger numbers on these. That's why we don't want to graph all of them. Okay, because some of them are bigger numbers and then the graphing just doesn't work quite as well for us. Okay, so that's the substitution method. Okay, next we're going to look at the elimination method. Okay, so if we move to example 3 now. Okay, so for the elimination method, we do need everything lined up. Okay, which means I need the y's lined up, the equals, the squared, the regulars, and the numbers. You'll notice these ones are not lined up because this one doesn't have a squared and this one does. Anything that's missing, we want to put in as a 0. Okay, so I'm going to rewrite the top one as 0x squared plus 28x plus 4. Okay, so I'll kind of squiggle that one out just for you guys, but we'll actually use it when we plug things back in. So whenever we eliminate, again, we want everything lined up. And again, we did this back in chapter 6, so hopefully it does look familiar to you. Okay, now what we want to do is we want the y's to cancel out. Well, for them to cancel out, I have to make one of them a negative. Doesn't matter which one. However, it's always easier to work with a positive x squared than a negative x squared. So if I have a negative x squared, then I'm going to change the signs on that one. Okay, so they become negatives. If that was a positive x squared to begin with, then I would have changed signs down here. Okay, just kind of depends. And then we're going to add them together. So the y's cancel, which is exactly what we want to happen. X squared plus 0x squared will still give me x squared. Negative 39x and positive 28x gives me a negative 11x. Negative 64 and positive 4 give me negative 60. Okay, so now we're at the point where you can choose factoring, completing the square, or quadratic formula. Again, they all factor pretty nicely, so I'm going to go ahead and choose that method. Factors in negative 60 that give me negative 11 would be negative 15 and positive 4. Okay, set those equal to 0. And you get the two x values that you need. So that means one of them is going to start with 15, and the other one's going to start with negative 4, and then I just need to find their buddies. Again, this one's the easiest one to plug it back into. So if you take 28 times 15 plus 4, you should end up with 424. And then again, plug in the negative 4, and you should end up with negative 108. Okay, so those would be our two answers once we plug them back in. All right, one more elimination one here. Alright, so again, if we're going to use elimination, we want to get everything lined up, which means I'm going to put in a 0x squared. And again, we'll come back to that one later. Okay, again, I have a negative x squared, which means that I want to change the signs on this one and add them together. So the y's will cancel out. X squared. Add those and we'll get negative 96x. And those two cancel each other out as well. Now this one you're probably looking at and go, wait a second, this looks a little weird. Yeah, it kind of does here initially. There's really two methods you could use here to solve this one, either factoring or quadratic formula. Probably wouldn't want to try to complete the square with that one missing. It kind of would get a little messy along the way. Okay, again, factoring to me is the easiest. I can pull out a GCF of x. And when you pull out your GCF of x, you're really done factoring because you no longer have an x squared on the inside. Okay, so I just end up with x equals 0 and x minus 96 equals 0. It actually ends up being faster, okay, than our typical ones. Again, you could have used quadratic formula, just putting a 0 in for the c as well. Okay, so we'll end up with 0 and 96 is the 2 here. Okay, so you'd want to plug your 0 back in and end up with 15. Plug the 96 back in and we'll end up with 2,319. So you can see you can get some bigger numbers with these and that's fine. Okay, so again, we're just going to focus on the elimination and substitution. You can skip the graphing methods. We aren't going to do those ones. All right. Otherwise, that kind of wraps up things for this year. So that'll be it for teaching. Okay, we'll just kind of wrap up with our quiz, and I hope you guys have a wonderful summer. I'm sure some of you will have in class next year for geometry as well, which will be awesome. Yeah, hopefully we can get back to having a normal school year next year. Okay, have a great summer, guys.